Hi, Algebra 1. So I figured I'd try something a little different for our assignment this week. I think that we should definitely spend some more time practicing problems from section 6.1. It definitely seems that people need a little more practice and review for graphing lines. So what I've created for this week is an interactive worksheet, and basically I'm going to be working in the same worksheet that you will be working on. So I'm going to zoom in, view, zoom, zoom in, so we can take a look at the instructions. So this is going to be one of our week 5 assignments. It says solve each system by graphing. Use the odd problems to guide you through the following even problems. Use the text boxes to show your work. So basically what I'm going to do, all of the odd problems will be guided, and I'll walk you through how to do them. You'll then use the odd problem to help you do the corresponding even problem. So for example, I'm going to do number 1. You'll use number 1 to guide you through how to do number 2. I'll do number 3. You'll look at number 3 to help guide you to do number 4. I'll do number 5. You'll go to the next page and use it to help you do number 6. And then lastly, I'll do number 7, and you'll use number 7 to help you with number 8. So let's go ahead and get started. So we learned last time that a system of equations is simply 2 equations, and in this case we're going to be looking at 2 linear equations. So one way to solve that system is by graphing. So I've got 2 lines here, so I'm going to have to use that for my graph. But before I can graph, I should observe what type of lines I'm even working with, right? Like what form they're in. Therefore, that's going to tell me how to graph it. So what I've done is I've put text boxes near each equation, so that way you can click and type different things about that line. So if I look at this first equation here, x equals 4, I notice that it doesn't have a y. That's going to be a very special type of line. If it's x equals a number, that is a vertical line. So what that means is that I find the number 4 on the x-axis, because that's the variable that's being used, and I draw a vertical line through it. So that's what I'm going to do first. So I'm going to take my arrow, and I'm just going to put the tip of the arrow on some sort of point here that if I dragged the other arrow and made a vertical line, it would pass through x equals 4, okay? And I'm going to drag that all the way across my graph. Again, we want to maximize the amount of space that our lines are taking up, because we don't know where the point of intersection is going to be. It could be somewhere in the middle, it could be somewhere up here, it could be somewhere down here, but we're looking for the point of intersection if there is one, because that's going to be the solution. If there is no point of intersection, remember that the answer is no solution. And if they overlap, your answer is infinitely many solutions, which we abbreviate as IMS. Okay, so that takes care of equation number 1. It's a vertical line, passes through this point here. Next equation is in slope-intercept form. Some of you should really review section 5.3 for how to graph equations in slope-intercept form. So in order to graph an equation in slope-intercept form, you're going to identify 2 things. You're going to identify the slope, and the slope is the thing that's touching the x, so in this case my slope is 1/2. And you're also going to identify the y-intercept, which we call the b-value. The b-value is just the constant that sits by itself, which in this case is -1. In order to graph this equation, we need to start at the b-value, which is sitting on this y-axis, where my cursor is hovering. So I'm going to find -1. Here it is. I'm going to line up the tip of one of my arrows with that y-intercept. Then I'm going to have to move this a little bit. I'm going to shrink this. Whoops. I want it to be straight as possible. It can be a little bit tricky to do this. So I just moved my scroll bar over to the left so I could get this little circle here, because that's what allows me to grab the other arrow. So once you've lined up one of your arrowheads with the y-intercept at -1, you're then going to grab the other arrow, not the same one that you started with, but the other one, And do this very, very carefully, okay? You're going to use the slope to rise and run. Remember, the numerator is how much you rise, denominator is how much you run, and it is a positive slope. So that means that when I'm done graphing, the line should be rising like this. See how it's sloped in a positive way? Remember, puff, puff, positive? If it was negative, it would slope like this. So what this is telling me is that from this point here, this y-intercept, I need to rise up 1, because that's my numerator, and then go to the right 2, because that's my denominator. See how both of those directions are positive? Up 1, right 2. And I'm going to do this for as many times as my arrow will fit. Up 1, right 2. Notice how I'm going kind of slow here? Now I could take the other arrowhead, which is where my y-intercept is, and reverse both directions. I could go down 1 and left 2, down 1 and left 2. I can't go left 2 again, so I'm not going to bother going down 1. And if you notice, see where the tip of the arrow is touching that red line? That's my point of intersection. That's my final answer. So I need to make sure that I write that as an ordered pair. So remember, the x value goes first, and that's going to be the x value for this ordered pair. It crosses at an x value of 4. I'm going to write a comma, and then I'm going to write the y value. The y value is right here, 1. So my ordered pair, my point of intersection, is at 4, 1. We had a vertical line and an equation in slope-intercept form. I plotted B first. I used the slope to plot more. Point of intersection is written as an ordered pair. Use number 1 to help you with number 2. So you kind of have some similar looking equations here. I'm going to jump to question 3. So I actually encourage you to do your assignment while you're watching this video. So what I would do before you watch me do question 3, I would pause the video, use number 1 to help you with number 2. When you're done and you feel like you're confident in your solution, then continue watching this video. Okay, so hopefully at this point you've paused the video and you've given number 2 a try. I am going to move on to number 3. Both of these equations are in slope-intercept form because the y is by itself. We've got a slope value touching the x and a b value. So I'm going to click in this first text box, which corresponds with the first equation, and I'm going to list both of those things. I'm going to list the slope, which is 5/4, and I'm going to list the b value, which is +1. And then I'm going to go down here to one of my lines, and I'm going to start to graph this. So again, I need to use the b value to help me graph. So I'm going to take it, and I'm going to line up this arrowhead right here with the b value, which is +1. So I'm going to line it up with the +1 that sits on the y-axis. Then I'm going to take the other arrowhead, and I'm going to move it from this y-intercept. So I'm going to go to the y-intercept first, and then from here, I'm going to move it based off of how the slope is telling me to move. Well, the slope's telling me to rise 5, so up 5, and then run 4, so to the right 4. But if you notice, 1, 2, 3, 4, I don't have the space to do that. I can't go up and right, but I can go from the y-intercept down and left. And remember, you want to move in such a way that it's positive because my slope is positive. If it was negative, you'd want to move in such a way that your line would look like this. So I'm going to go down 5, 1, 2, 3, 4, 5, and I'm going to go to the left 4, 1, 2, 3, 4. And this is one of those graphs I can only seem to fit 2 points, and that's okay. Hopefully it'll be enough for us to find our point of intersection. All right, so same thing as the previous equation. I need to look at this equation and identify some things in order to help me graph. I'm going to look at the slope first. The slope is the same thing, 5/4. And then I'm going to look at the b value, which is +3. So you might already have noticed before I even started typing anything, these lines are parallel. Now, if you recall from our first lesson, if you have 2 parallel lines, they're not going to intersect. You might even be able to answer this right away. I still want you to go through and do the graphs for both. It's practice. You want to make sure you're not getting rusty with how to graph. So I'm going to take this green line, and I'm going to line up the rightmost arrow with my y-intercept at +3. I'm going to take my other arrow, go to the y-intercept, and use the slope to move. I can't go up 5, but same as last time, I can go down 5, 1, 2, 3, 4, 5, and over 4. And just like last time, my slope is positive, so if I want that positive slope, I'm actually going to have to move to the left. So 1, 2, 3, 4. And that's as many points as I can plot for that line as well. They're parallel, which means they don't intersect. And if two lines don't intersect, there is no solution. And that's actually what I need to write as my final answer. If you typed an ordered pair here, that's wrong, okay? So I encourage you to, again, pause the video or rewatch it from this point, from this question, and use number 3 to help you with number 4. All right, so at this point, I'm assuming you've paused the video, you've given number 4 a try, so I'm gonna move on to number 5. I'll guide you through 5, use it to help you with number 6. Okay, so looking at the first equation, I noticed that there's only a y and there is no x. So remember, just like in number 1, if you only have one variable and not both, it's gonna form a special line, either vertical or horizontal. If it's y, stick your arms out and fly. It makes a horizontal line when you do that. So y equals a number is a horizontal line. So what that means is you're going to find -2 on the y-axis. So here it is. And you're going to draw a horizontal line through it. I'm just going to drag this line here because it's already horizontal and place it over that y value. Okay? There's my first equation. Y equals a number is a horizontal line. Okay, the next equation is in point-slope form. That means by looking at this equation, there should be a point that's visible in it and a slope. Remember, the slope is the thing that touches your parentheses. The point you actually have to get from the numbers that are near the x and the y. Let's do the slope first. M equals negative. This is really a number. It's an invisible 1. So my slope is -1, and it's always a good idea to make your slope a fraction if it isn't 1. So I'm going to put this over 1. Now the point, I'm going to have to get the x value for my point from the number near the x value. But do you remember what we have to do to the sign for point-slope form? We have to reverse it. So my point here does not have an x value of -2, but it's actually a +2. And it has a y value, so I'm looking at the number near the y, of not +1, but -1. Remember, you got to reverse the signs for point-slope form. That comes from the fact that in the equation itself, there are minus signs in the equation. So I need to start by plotting this point and then using the slope to help me plot more. So kind of similar to when I did it in slope-intercept form, I'm going to take this line and line up this arrow here with wherever this point is. This point is at 2, -1. That means that from the origin, I got to make sure that that tip of the arrow goes to the right 2 and then down 1. Go real slowly, okay, to do stuff like this. You may even want to zoom in a little bit more. Again, to do that, you'll go to View, Zoom, Zoom in. And let me just show you one more time how I did that. I took this line, I lined up, see how when I start dragging it, you can kind of see the line moving a little bit. I lined up this rightmost point with the origin first. You want to start at the origin when you're plotting an ordered pair. And I went to the right 2 times and then down 1. 2, -1. That's how I did that. So I don't want to move this arrowhead because this is sitting at this point here. I do not want to move this. So in order to use my slope to plot more, I'm going to go over to this arrowhead. I'm going to drag the circle and I'm going to move it based off of how the slope is telling me. My slope is negative, so however I plot my points when I'm done, this line should fall. like this. It should be a nice negative slope. Imagine Mr. Slope did skiing down that slope. It should not rise like this, okay? That's a puff, puff positive. So I'm gonna go to this point here, which is where the tip of the other arrow is, and I can either rise one and run one. But if I rise in order to get that negative slope, I gotta go left. See how I'm moving in such a way that my slope falls? So I'm gonna keep doing that. Up one, left one, up one, left one, up one, left one, up one, left one, up one, left one. I wanna maximize the amount of space on my graph. Go real slow when you do this. I'm actually gonna go back to this ordered pair, and I'm going to click and drag this arrow the same way that the slope is telling me, but I'm reversing both directions. So instead of going up and left, I'm going to go down and right, down and right, down and right. So you may be thinking, well, don't I lose that point that I just plotted? No, it's actually still here. The arrowhead just isn't where it is. I just have my lines sitting over it now. So there's still a point right here at 2, -1, okay? And now I look for my point of intersection. Here it is. So I need to write this as an ordered pair. It's at the point 3, -2. Okay, so I'm going to write that in parentheses. I'm going to click on this text box. You may want to undo the underline so there's no underline in your ordered pair. Not a huge deal if you don't. So it was at 3, -2. Okay, I'm actually going to zoom out. I like the other view a little bit better where I can see more. Zoom out. There we go. That's a little bit better. All right, so to recap, we had a horizontal line, and then we had a point slope equation. I had to name the slope and the point first. I plotted the point by lining up my arrow at that location. I used the other arrowhead to drag my line, and then I used the original arrowhead to drag my line in the opposite direction, and there's my point of intersection. Use number 5 to guide you with number 6. I encourage you to pause the video, maybe even rewatch that part again while you're doing this one before you move on with the video. Okay, so at this point, I'm assuming that you've paused the video and you've given number 6 a try. Now let's move on to what has been the hardest type of equation for pretty much all students across the board. And that is when I give you an equation in standard form, because I've asked you to convert your equations from standard form to slope-intercept form, just because it's going to be a little bit better with graphing electronically, with having to do your graphs like this. So as you can see, I've set up these problems a little bit different from the ones above. I have more text boxes, and it says equation 1 workspace, equation 2 workspace, and then our final answer. And I got to change this. This is number 7, and this is number 8. The other one's good? I think so. A little impromptu review here, just to make sure that everything's typed out correctly for you guys. Yes, okay, good. So basically, what I want you to do is what I'm going to do here. I am going to retype equation number 1, so -3x minus 6y equals -18. I'm going to actually space some things out here so we can see the signs a little bit better. So what I want you to do is I want you to get the y by itself for each equation. So I have to do this with equation number 1, do some calculations to get the y by itself. I have to do it with equation 2, do some calculations to get the y by itself, graph each of them, and then find the point of intersection if there is one. In order to get the y by itself, you're going to follow these steps. You're going to get the x term over to the right first. In order to move the x term, you add or subtract it once from each side. Look at the sign that you see. It's a negative, so I'm going to add it because that's the opposite. Add 3x, add 3x. These cancel, so I'm left with a -6y equals, so don't forget that there is a negative sign in front of your y term, okay? If you're looking at a standard form equation where there's a minus sign in front of the y, you gotta make sure to bring that down in your next step. Several students were forgetting that, like if there was a -y or a minus and then a number and then the y, they were forgetting about this minus sign here. That counts as a negative in front of the y. All right, and then at the right, I can't combine these two terms. All I can do is put them next to each other. I'm going to put the positive 3x first, and then the minus 18. And the reason why I'm putting the x term first is because in slope-intercept form, the x term goes first. All right, so step number 1, get the x term to the right. We did that. Step number 2 is to get the y by itself by dividing by whatever number is in front of it. So that means that I need to divide by -6, because I want to get rid of not just the 6, but the negative also. So I'm going to divide by -6 to get the y by itself. When you do this, you do it to all 3 terms. So divide by -6, divide by -6, and divide by -6. Careful if you're using a calculator here. We're going to get a fraction for one of these. Y is now alone. Okay. I'll capitalize it. Leave it like that. Okay. Now, if you did this in a calculator, it's going to tell you that it is -0.5. Remember, this number is touching the x. We don't want a decimal because we want it in fraction form to see what our rise and run is. So think about what 0.5 is as a fraction. It's -1/2. And if your calculator is fancy enough, it'll actually convert decimals to fractions for you. All right, so I have a -1/2 x, and then -18, again, don't forget that negative, -18 divided by -6 is going to give me a +3. Here's my final equation for number 1, equation number 1, written in slope-intercept form. So I'm going to go ahead and graph that. So my m value here is -1/2. My b value is at +3. So I'm going to start by graphing my y-intercept, line up one of my arrows with +3. Go to my other arrow, and I'm going to make sure that when I graph my points, my line falls. So my line should look like this. So I can either go, up 1 and left 2, up 1 and left 2, see how my line's falling? Or I could go back to the original and go down 1 and right 2, down 1, right 2. And again, you want to do that for as many points as possible. We want to maximize the amount of space because we don't know where that point of intersection is going to be. All right, I'm going to do the same thing for equation number 2. X plus, that's not an x. X plus 2y equals 6. And same order of steps as last time. Get the x to the right by doing the opposite. It's addition or subtraction. Well, if I look at this x term, there's no minus sign to its left, so it's positive. So to get it to the left, or excuse me, the right, I'm going to subtract x. These are going to cancel. And I do the same thing to the right. So I'm now left with 2y. I don't need to write the positive or the plus sign in front because it's understood to be there if I don't write anything. And again, I don't combine these. I simply write the -x first and then +6. Now I do need to put a plus sign because there needs to be an operation in between these two. Next step was to divide all 3 terms in my equation by whatever number sitting in front of the y. I do the same thing here. I'm going to divide all terms by 2. Divide by 2, divide by 2, divide by 2. Okay, so y is now alone. And again, if you did negative, and there's an invisible 1 here, so this is -1 divided by 2, your calculator is going to give you a decimal. We want a fraction, so do -1/2. That's the number in front of my x. 6 divided by 2 is going to give me +3. So same as last time. In order to graph this, I'm going to list what the slope is. It's -1/2. I'm going to list what the b value is. It's +3. And when you look at that, it's actually going to wind up in the same location. So I'm going to line up one of my arrows. Again, I want you to still graph both of them. I'll line up one of my arrows with the y-intercept at +3. And again, my slope is negative, so my line should fall. I can go up 1, left 2, up 1, left 2, or I could drag the other arrow and go down 1, right 2, down 1, right 2. So as you can see, the lines end up overlapping. From our previous lesson, when that happens, they're intersecting everywhere. And they're going to intersect for infinity, okay, for infinitely many points, because those lines will extend for infinity. There's no end. That's what the arrowheads mean. So I'm going to write as my final answer, infinitely many solutions, or IMS is how I like to abbreviate it. Use number 7 to guide you through number 8. Okay, if you run into any issues where you can't do this worksheet because a couple of people were running into that problem, please let me know as soon as possible. I'll try and make a copy of it, try and find some sort of solution. And of course, if you have any questions, just reach out. Take care, guys.